So, good day, engineers. Our topic for today is all about geothermal power plant. So, what is clearly a geothermal power plant? So, it is a facility that converts heat energy from the earth into electricity. It works by tapping into underground reservoir of hot water or steam, which are brought to the surface through wheels. This thermal energy is then used to drive turbines connected to generators, producing electricity. After use, the cold water is typically re-injected back into the ground to maintain reservoir pressure and sustain the system, creating a closed-loop process. So, kanang geothermal power plant, nana siya process usaon pag-harness sa iyang energy gikan sa underground sa earth. So, makita na nato sa next slides kung unsa ang iyang process. So, why is geothermal power plant important? Geothermal power plants are important because they provide a stable, reliable, and continuous source of clean energy. Unlike solar or wind power, geothermal plants can operate 24/7, regardless of weather or time of day, making them ideal for delivering baseload power that balances the intermittent nature of other renewables. This reliability enhances grid stability and supports the transition to a carbon-free energy system. So natay three primary types of geothermal power plants, which is the dry steam, flash steam, and the binary cycle. So the dry steam. Dry steam geothermal power plants are the oldest and simplest type of geothermal power plants, using naturally occurring steam directly from underground reservoir to generate electricity. The steam typically at temperatures above 150 degrees Celsius or 300 degrees Fahrenheit. It is piped from production wheels to a turbine, which spins to drive a generator and produce electricity. After passing through the turbine, the steam condenses into water and is usually reinjected back into the ground to maintain reservoir pressure and sustainability. And next is the flash steam. It is the most common type of geothermal power plants in operations today, utilizing high temperature geothermal resources, typically above 180 degrees Celsius or 360 degrees Fahrenheit, to generate electricity. Next is the binary cycle. It is a type of geothermal power plant that generates electricity using a secondary working fluid with a lower boiling point than water. It operates by transferring heat from geothermal fluid, or typically water or brine, through a heat or exchanger to vaporize the secondary fluid, which then drives a turbine connected to a generator. The geothermal fluid remains in a closed loop and is reinjected into the reservoir, while the secondary fluid is condensed and recycled, making the system closed and emission free.
Geothermal energy process. Geothermal energy harnesses heat from deep within the earth, originating from the planet's formations and radioactive decay to generate electricity or provide heating and cooling. The process relies on hot water or steam extracted from underground reservoir to drive turbines connected to generators. There are multiple types of geothermal power plants, but all follow a core sequence of steps to convert Earth's thermal energy into usable electricity. So, based in this diagram, that hot water or steam from underground reservoir heated by hot rocks and magma to the surface where the steam spins a turbine connected to a generator to produce electricity. After steam is cooled in cooling towers and condensed into water, it is re-injected into the ground through an injection well so the geothermal cycle can continue. Three advantages of geothermal power plant. First, significant cost saving. Second, reduced reliance on fossil fuels. Third, environmental benefits. So, significant cost saving. Geothermal energy generally involves low running costs since it saves 80% cost over fossil fuels and no fuel is used to generate the power. Second, reduce reliance on fossil fuels. Dependence on fossil fuels decreases with the increase in the use of geothermal energy. With skyrocketing prices of oil, many countries are pushing companies to adopt these clean sources of energy. Lastly, environmental benefits. Being the renewable source of energy, geothermal energy has helped in reducing global warming and pollutions. Moreover, geothermal systems does not create any pollutions as it releases some gases from deep within the earth, which are not very harmful to the environment. I have three limitations of geothermal plant. First, high installation cost. Second, suitable to particular region. Third is may release harmful gases. So, high installation cost. To get geothermal energy requires installations of power plants. To get steam from deep within the earth of this require huge one-time investment and require to hire a certified installer and skilled staff needs to be recruited and relocated to the plant locations. Suited to particular region. It is only suitable for regions where temperature below the earth are quite low and can produce steam over a long period of time. May release harmful gases. Geothermal sites may contain some poisonous gases and they can escape deep within the earth through the holes drilled by the constructors. To further understand the working principles of geothermal plant, I have here a short video to watch.
Planet Earth. It's hot and full of energy. If you've ever observed an erupting volcano, sat in a geothermal hot spring, or visited the geysers at Yellowstone National Park, you've experienced geothermal energy. The deeper you travel into the Earth, the hotter it gets. The Earth's crust is made of rocks and water. Underneath the Earth's crust is a layer of hot molten rock called magma, which is even hotter than the Sun's surface. This Earth heat, also called geothermal energy, is a clean, renewable source of both power and heat. The energy from less than 10 kilometers deep contains 50,000 times more energy than all the oil and natural gas resources in the world. Globally, geothermal currently generates enough electricity to meet the needs of 60 million people. We can harness this vast energy by developing geothermal power projects, or geopower. Using today's technology, we can locate and drill into the geothermal resource at only a few kilometers deep and capture the rising hot water and steam. Releasing a small amount of that heat in the right way can create electricity, and the formation water is re-injected back into the same reservoir underground to be reheated and recycled. Binary turbine power plants use hot formation water to vaporize another fluid. The second fluid drives a turbine and generator to produce electricity. This closed-loop system produces no emissions and has one of the smallest environmental footprints of any power supply. Geothermal plants provide power 365 days per year, 24 hours per day, and projects are designed to operate a minimum of 20 to 30 years. Its clean electricity is delivered via power lines to your community. Borealis Geopower has a project goal to develop a 15 to 20 megawatt energy power facility. This is enough to provide clean, renewable electricity for over 15,000 homes. The advantages of geothermal do not stop at clean power. The geopower facility's waste heat can be used for a variety of community applications, including district heating for greenhouses, hot spring bathing, fish farms, and timber drying, to name just a few. By harnessing our Earth's heat resource, we can create a clean, renewable energy project that can grow your community today and create an ideal model for energy development for the next generation of Canadians.
I have one simple problem in geothermal power plant. In a geothermal power plant, the enthalpies of the groundwater and the turbine inlet are 1,500 kilojoules per kilogram and 3,500 kilojoules per kilogram respectively. If the enthalpy of the hot water in the flash tank is 700 kilojoules per kilogram and the mass flow rate of steam is 15 kilogram per second, what is the mass flow rate of groundwater? So, given enthalpy of groundwater is H1 equals 1,500 kilojoules per kilogram. Then enthalpy of turbine inlet steam is H2 equals 3500 kilojoules per kilogram. Enthalpy of hot water leaving flush tank H3 equals 700 kilojoules per kilogram. Mass flow rate of steam Ms equals 15 kilogram per seconds. So where mg is a mass flow rate of groundwater, then ms equals mass flow rate of steam. Then open parenthesis mg minus ms close parenthesis is equals mass flow rate of hot water leaving the tank. So solution is the energy entering the plus tank equals the energy leaving. So mg times h1 equals ms times h2 plus open parenthesis mg minus ms close parenthesis times h3. Then input the given value, then we get the mass flow rate of the groundwater is 52.50 kilogram per seconds. So from 52.5 kilogram per seconds of geothermal water, only 15 kilogram per seconds becomes the steam that goes to the turbine, while the rest leaves a liquid hot water. Conclusion: geothermal power is a critical clean energy solution for decarbonizing electricity systems, enhancing energy security, and supporting long-term grid reliability. That's all for this topic. Thank you.